Welcome to Check Your Understanding, Skill 1.1. I can define and use the definitions and equations of distance, displacement, speed, velocity, and acceleration. So, when we're looking at distance and displacement, almost everything you've probably done in your lives so far has been dealing with distance. But today, I'm going to introduce you to displacement. Distance is how far you have traveled. You've traveled 10 miles, 15 kilometers, 10 feet. Displacement, or change in position, is how far you are from where you started, and is also represented by the equation. This little triangle here means change. So it's the change in x. Now this change in x can be figured out by looking at our xf minus xi. Well, what do those two mean? Well, let me rewrite this again. Let's see. If I have this really means the change in your position, or change in x, then all I'm looking at is xf, the final position, and x sub I, which means the initial position. So where you started and where you finished. Okay, so now let's take a look at this table. Fill in the table based on the above graphic. Okay, so let's see. Let's try and figure out what's happening here first. So it looks like I have some kind of position. Maybe somebody's walking and they're going to walk this way and then they're going to walk back this way. Now notice when we're doing this, there's a little curve here, but the curve is really just to show distance between these two so you can actually see them. It doesn't actually mean that the person's going upwards. So really the person traveling is starting here at 1 meter. They're coming down here to 4 meters, and then they're going to travel all the way to 3 meters. Okay, so that's really what's going on. So let's take a look. All right, at time 1, what is the distance that the person traveled? Well, at time 1, I'm going from 1 meter to 3 meters. So the distance I've traveled is 2 meters. All right, that's the total distance that I've traveled. Now my displacement is change in x. Well, my final position, my x final, is going to be 3 meters minus my initial position, which was 1 meter, and that's going to give me an answer of 2 meters. Oh, check this out. Because this is a table, this is your first introduction to tables probably in this class, we don't want to have units in the table. So I'm actually going to go back. Big mistake. Oh my goodness, I should start this whole video over and erase that. All right, number 2, time at 2 seconds. So at 2 seconds, I'm here. At 2 seconds, I am right there. So that means, why is that so big? That means at 2 seconds, I'm going from here all the way to here. Okay. So the distance I've traveled is 1, 2, 3 meters. And my displacement, well, I'm at, my final position is at 4 meters minus 1 meter. It's 3 meters again. Whoa, those are the same. Okay. Pretty simple stuff if you ask me. Let's keep going. At 3 seconds, so now at 3 seconds, let's see what happened. At 3 seconds, I've gone from 1 meter all the way to 4 meters, and then I've come back to 2 meters. So the distance I've traveled, well, if I started at 1, then I go 1, 2, 3, 4, so that's 3 meters. So let's do this. 1, 2, 3, and then back 1, 2. So that to me looks like 5 meters. Is that right? 1, 2, 3, 4, 5. Yep. The distance I traveled was 5 meters. However, my displacement, I started, my final position was 2 meters. My final position was 1 meter. My displacement is only 1. And if we look back at that definition for displacement or change in position is how far you are from where you started. Well, if I'm at 2 meters, how far am I from where I started? That's just 1 meter. It all checks out. Here we go. At 4 seconds, let's see, at 4 seconds, At 4 seconds, I'm going from 1, 2, 3, 4, 5, 6, 7, 8. I'm seeing I've moved 8 meters. But my displacement, let's see, my final is at -1. My initial was at 1, so -1 minus 1. That's going to equal to a -2. So my displacement is -2. Now in physics, we're going to use negative a lot. It doesn't mean less. Like in math, you use it a lot for less. It doesn't mean less in physics. It just means in the other direction. So if I started here, it's saying my displacement is -2 from where I started. Oh, so 1, 2. And that's how I got to -1. All right, I hope that makes sense. Speed versus velocity. Speed and velocity, we use them interchangeably in most of our lives. However, now in this class, I need you to know that velocity is the speed of something in a given direction. Velocity is a vector, and that's a very important term. We're going to do a lot with vectors. He's so important, he's on my door, and he fights crime using magnitude and direction. It has both magnitude and direction. You may have come across this in another science class, as for example, I ran 2 meters per second to the south during a race. The 2 meters per second is the magnitude, and to the south is the direction. In this class, the direction will be given by a positive or negative magnitude. In the model below, consider the direction to the right to be positive. The velocity of the red car is 15 kilometers an hour. The velocity of the blue car is -5 kilometers per hour. What are some differences between the model of the blue car versus the model of the red car when it comes to velocity? Let's see, I would see this arrow is a lot longer than this one, and that has to do with the magnitude, right? If it's a bigger number, it should have a bigger arrow. And if we were to measure this, you'll see that this first arrow is actually 3 times the size of this arrow. So they are proportionally sized. What else? Ooh, this one's pointed to the left. And up here, it says it has -5 kilometers per hour. So this direction to the left must be our negative direction, and this direction to our right is going to be the positive direction. I'll keep that there. The vector arrows are different sizes because they're different magnitudes. Wait, I thought the velocity of the blue car was -5. Why is the negative missing from the model? Well, the negative is missing from the model because the direction is given by the arrow. And if the direction is given by the arrow, we don't necessarily need to put a -5, the negative in front of the 5 kilometers per hour. Okay, so that's the difference between speed and velocity. Moving on, acceleration. Acceleration is the rate of change of velocity. It is also a vector, meaning it has direction and magnitude. You experience acceleration every day. When you are in a car or a bus, it starts at 0 meters per second and then changes its velocity to something. As in an example, 8 meters per second. However, you don't instantly go from 0 to 8 meters per second. It takes time. In our example, let's say it takes 4 seconds. Acceleration is a change in velocity divided by the time it took to change that velocity. Therefore, acceleration is the change in velocity over time. My change in velocity, I went from 0 to 8, so my change in velocity was 8 meters per second. It took me 4 seconds to get there. 8 divided by 4 is 2, and I get an answer of 2 meters per second squared. Notice this squared. Why is that squared there? Well, that's one of our definitions of acceleration because it's time, it's the velocity changing over time. And look at our equation here, right? I have 1s here, I have 1s here. That is why we have this seconds squared. Let's try the one below it. If a car has a velocity of 4 meters per second and accelerates to 20 meters per second in 10 seconds, what is the car's acceleration? Well, if the change in velocity then of this car is going to equal, let's make a little arrow here so people can see. So this one I'm going to put right up here. The change in velocity, I went from, my final velocity is going to be 20 meters per second. My initial velocity was 4, and it took me 10 seconds to do that. Well, 20 minus 4 is going to be equal to 16. 16 divided by 10 is equal to 1.6, and my units are going to be meters per second squared. All right. If acceleration is a vector, then what does a negative sign mean for acceleration? Example, if a skateboard is moving 9 meters per second and its acceleration is negative 3 meters per second squared, what does that mean? Well, it means that it's slowing down. If this is a positive vector and this is a negative vector, it means that it's slowing down. Now, if the skateboard was actually moving at a negative 9 meters per second, moving, let's call it negative to the left, right? It's moving there at negative 9 meters per second. Well, if it has an acceleration of negative 3 meters per second, then it's actually going to be getting faster. But in this example right here, it is slowing down. All right, here's some equations for us. The meaning, you can find these up above. This is just going to be change in position. Equation, change in x is equal to x final minus x initial. Here we have our average symbol. Ooh, that's cool. A little line above any of these means the average. My average velocity is equal to change in x over change in time. So a change in velocity. Well, I could actually look up here as a clue. My change in velocity is going to be the velocity final minus the velocity initial. And average velocity is equal to the change in position divided by time. So, sorry, if I go up here to this displacement is equal to the final position minus the initial position, I can say my change in velocity is equal to the final velocity minus the initial velocity. And acceleration. We saw that A stands for acceleration. Acceleration, we saw our equation up there is going to be a change in velocity divided by the time. Acceleration is the change in velocity divided by the time. And, ooh, whoa, you know, it's actually pretty cool. If I have this equation right here, A is equal to change in V divided by T. If I multiply the T on both sides, what happens is this cancels out. Oops, sorry, the second one doesn't cancel out. And I can get a change in velocity by multiplying acceleration times time. That's interesting. So really, change in velocity has two ways that we can get it. All right, all right. And that's it. Lots more of this to come. Hopefully this was something that allows you to get started in this class and check your own understanding. I look forward to seeing your learning. Thank you. Bye.